That's a very good example actually. So these are actually the images through which we can spin a system really quick, right? And containers are actually single individual unit where, for example, if I ask you to install Java, right? So what all you will need an OS, you will need some compute power, and then you can install Java and run your program. Very simple in container. So these are very small unit of packaging, you can say, which we call image as well, Docker image. And you can, within a system, you can define the different resources. If you have 16 GB RAM, 4 core CPU, you can allocate what should be the size of individual image, and within a system itself you can host multiple container. And the benefit of container is you will be realizing, and those who have already programmed and demoed your application to one of the like as a presenter, if you do so in general, and this happens to everyone at any given point of time, this happened to everyone. So you work on a code, you make this presentable, but as soon as it goes on production, it fails. Or if you are going to give a demo where you worked and your application has been running successfully, but you will realize at the time of demo it fails, right? The reason is, for demo, if we are changing the machine, for production release, for QA release, some of the configuration that we change is generally take us into a situation where we are where we feel embarrassed that the application was running fine just 5 minutes back, why it is failing now. So container can also be one of the solution to that problem. You can build your application, you can provide all the dependencies in the container, and when you make this application moving from one place to another place, you will see that nothing is breaking out, right? So two examples I talked about. One is creating an individual programming unit, which is having all the dependencies required to run your software. Perfectly. The other benefit, which is an implicit benefit of it, it makes your program runnable irrespective whether example of it. Okay. Yeah. Any question, guys?
Sir, what is the difference between sandbox and container?
Sandbox, if we talk about, that is and just help me understand, like sandbox, when I look at it, it is like kind of a testing environment, right? Where usually companies, those who want to give their product for evaluation, they create a sandbox environment, which is not actually a production environment, but it is more like a testing environment with limited functionalities, with less CPU usage allocation, so that you can, as a user, you should be able to evaluate it. But as soon as it goes on production, there will be different compute power, different functionality, some of it maybe. So that is the sandbox, how I look at it. Do you have any other relevance to sandbox?
Sir, as a follow-up, the difference in virtual environment.
Right, so virtual environment is something like you can think of a bigger picture, right? So let me also move to our PPT. So when we talk about virtual machine, we have a couple of things here. We have like we remotely access it, right? We remotely access this one. It has all the things that requires to use your PC, which means it has some like accessibility through the viewer experience. And then it has RAM, OS, hard disk, and basic thing. And then on top of it, what you do is you install your software and make this as a workable PC for you, right? The difference is the system is not available directly, but you are connecting it remotely. Now, what is container? Let's think about a PC, and within this PC, you don't want to access it directly, but what you want your program to run. So the use case is different. Like you are not logging onto this machine and making it runnable, but you want some environment which is making your things running. You don't want any like accessibility from the users usability perspective, but you want your program to actually support in terms of running. Now this is, let's suppose, 16 GB machine, and you want to virtually divide this into multiple containers. So what you can do is you can create 4 containers in it, and each with 4 GB utilization. Now, why this is important? If you run a program on this machine itself that takes up to 4 GB of RAM, right? So you are actually not utilizing rest of the capability or the compute power of this machine, right? But if you break this machine into 4 different containers, you are 100% utilizing it. So obviously when we design the system, we are not 100% utilizing. Most of the time we are close to 100%, but you will see that all the resources are utilized efficiently to give you the maximum usage of this overall system. And then we are not just dividing the hardware usage, we are also saying that this may be like this may be running on let's say that Java, another one is running on Python. So obviously their dependencies will be different, right? And if you take this Docker image to some other place, it will run effectively. The reason is the number of dependencies that you specified while creating this Docker image, that will not change. As soon as you move it from one place to another place, it will first load those dependencies to run this program. So that is the benefit of making the containerized approach. And when it goes on the cloud, so like the virtual machine can be spun up, similarly this can be scaled up to the infinity. I hope this is clear, Sarthak.
Yes. Sir, what is
So Docker images, let me show you. I have this installed. It will take some time to load. So this is one of this is desktop version of Docker, and this is currently initializing the engine. So on the YouTube channel that I talked about, that I do manage, I created one course on Flowable, and this Flowable is actually a BPM engine. So on that, there are multiple ways to initiate it. For example, I may want to install that as an enterprise version on my machine, or I can make this portable using the Docker image. So what I did is I created one Docker image, and then I set up this complete software on the Docker image itself, which means all the underlying OS requirement dependencies, these are fed in this Docker image. So let's this run, and then I'll show you. right? So as you can see that this is runnable version of my how the Docker is running. Then I'm telling, like, these are all the commands, right? So these are all the commands what all are required. So one thing is I need Tomcat, then I'm setting the user for it, I'm setting the working directory, I'm saying what port it will run on, what should be the Java memory that it will be using, what is the path for it, what is the Catalina home. So those who are from the Java background, they should be able to correlate with it, and then what all files it will need to actually run this flowable engine. So all these configuration is actually part of the image, right? And then when this configuration loads, irrespective whether it is running on my machine, it may be running on someone else's machine as well, these commands will run. As far as these are connected to the internet, they will load. You can certainly see that these are some of the commands, and which talks about what are the dependencies and how these commands are basically executed in a logical manner to make up and running of your program. In the Python, I believe, I'm not from the Python background, but in Python similarly they must be downloading the Python version on any software, any application first, any OS. Then they must be running some commands to make Python up and running, and then they are loading the programming unit of like what they want to execute and then running it. So similarly, this is the image history which talks about it, and there is a complete complete containerization course which if you will follow on Docker and Kubernetes, that will give you more idea. But this is one of the example that I quickly showed you.
Means, sir, you are saying that after creating a Docker image, then it will make the containers in the machine that we are using.
Right. So this is Windows machine from where I'm giving you this demo, but you will notice that all are these actually Linux command, Unix command, right? This SH and all those things. So what it does, it created one Unix virtual image on my system, and on top of it, it executed all these steps to make this flowable engine up and running. Does that answer your question?
Yes, okay.
Okay, so moving back to this again. So like containers, these are single unit. Similarly, on top of it, we have Kubernetes, which actually manages these containers, and that is an advanced topic of how to manage the containers. So I even started learning it recently, but I have not used it in any of the project. And all the cloud service AWS, they have container registry, Amazon Container Registry, ACS, and then ECS, whereas in Azure they have AKS, Azure Kubernetes Services, to maintain all these things, and they also have the container registry. Now the next topic is what is CDN, Content Delivery Network.